Stan Gibilisco here with a little explanation of why you only need a mirror half as tall as you put on your wall in order to see your full reflection in that mirror. Have you ever noticed that if you're 6 feet tall, for example, you only need a 3-foot tall mirror in order to portray your entire reflection? Here's why. I'm going to show you some geometrical optics. This comes from my book, Optics Demystified. Figure 2-3 in that book looks like this. And it's a geometrical optics illustration of why you only need a mirror half as tall as you to see your whole reflection. Here's you. Here's a wall with a mirror on it. Suppose that you are 6 feet tall precisely, from the sole of your foot, from the tip of your shoe to the top of your scalp, right there, 6 feet. And you stand 5 feet in front of the wall, looking at yourself in this full-length mirror. By full length, it means it'll reflect your entire body. This mirror only needs to be 3 feet high, starting at this point up here and going to that point down there. And to illustrate that in terms of geometrical optics, you can imagine your virtual image on the other side of the wall, reflected laterally, virtual meaning imaginary, or as it appears reflected in the mirror, as you would look if the mirror weren't there and your nemesis, or what do they call that, doppelganger or something like that, your duplicate in another universe came from far away in the reaches of intergalactic space and stood on the other side of that wall. Here's your eye right there. There's the top of your scalp. A ray of light travels from the top of your scalp, strikes that mirror. The angle of incidence equals the angle of reflection, so it comes right back to your eye after reflecting from that point. Similarly, from your foot, your eye follows a line of sight, reflects from the mirror. The angle of incidence equals the angle of reflection. A light ray comes from your foot, reflects, and reaches your eye. If you want to draw that in terms of the virtual image over here, you can imagine this line of sight as a straight line extending through the wall down to the foot of your counterpart from the other universe. And similarly here, your eye sees a ray traveling in a straight line from the top of the scalp of your duplicate from some other universe where the galaxies look just the same. It's just that they're all made of antimatter instead of matter. Let's hope that those two universes never collide. So that's the geometrical optic diagram showing why you only need a 3-foot tall mirror to see your whole body reflected from the wall if you're 6 feet tall. If you're 5 feet tall, you can get away with a 2.5-foot mirror. And if you're into measuring in terms of the metric system instead, if you're 1.8 meters tall, then only 0.9 meters is the height that you need, but you have to place that mirror just right. You have to place it so that the top of the mirror coincides with the reflection point of this ray, and the bottom of the mirror coincides with the reflection point of that ray. Stan Gibilisco signing off from the Sombrero Galaxy in the antimatter universe. I am in fact not Stan Gibilisco, but his counterpart from that universe. Until next time, so long.